Welcome back, my dear students. Now we are going to study about open channel flow. This is one part of the fluid mechanics, and in this one we are going to study that name itself says that there will be a channel. Through the channel, flow will taking place. Usually we will consider here water only. The water is flowing through a channel, and one more word is there, that is open, means this channel where the water is flowing, that surface of the water is open to the atmosphere. Therefore, this is called as open channel flow. And the other that opposite to this one, we have a pipe flow. Pipe flow means where the fluid is flowing through the pipe. There the fluid surface is not open to the atmosphere, and the fluid will be flowing through the that whatever pressure only. But in open channel flow, the fluid flow takes place because of gravity. How to characterize a particular flow is an open channel flow or that is a pipe flow. Just you observe the water surface. If this water surface is free to the atmosphere, then that is a open channel flow. Then what are the examples of open channel flow? Irrigation canals, streams, rivers, navigation canals, or otherwise drainage channels, sewer lines and sewers. These are all examples of open channel flow. Okay. Now, the flow in the open channel flow is largely turbulent, therefore, the surface tension will be neglected. Here, in this entire chapter, surface tension is ignored. That is negligible, therefore, ignored. Okay. All open channel have a bed slope, hence gravity flow is the main force causing the flow. Here, see, I told you that the surface is subjected to the atmosphere, that is open to the atmosphere, means who is dragging this water from one point to other point, who is pushing that one, who is pulling that one. That is only a gravity. When a gravity has to work on the particular flow, then it should have a slope. Therefore, the bottom of the channel must be a slopy in nature, so that the gravity will attack on the water and it will pull the water to downwards. That is the main governing force for open channel flow is gravitational force. Then what is the opposing force? What is the resistive force? Is there any resistive force to the flow? Yes, there is a resistive force, that is your channel perimeter. Say for example, if this is a channel is a rectangular channel, then where the water is moving, then the perimeter where that water is that water rubbing the perimeter and it is moving, there it will get some resistance. Therefore, gravitational force is the main dragging force and the resisting force will be the surface force. Okay, the surface of the that is a perimeter, wetted perimeter will offer some resistance to that one. As a gravity is the driving force, Froude number is the main non-dimensional number. We are going to use it here. We have many numbers that you studied in a previous chapter. Froude number, Reynolds number, Euler's number, Mach number, that like that many numbers are there. Non-dimensional numbers they are, but here the gravitational force is the predominant one, therefore we are using Froude number here. What about in open pipe flow? In pipe flow, viscous force is there, therefore there we are going to use Reynolds number. Right? Here Froude number we are going to use. The water surface represents the hydraulic gradient line if the slope of the channel is small. Just look at here, I am going to draw this surface. Look at here, if this is a slope, this is the bottom line and this is a flow of water. Then this line is a top surface of the flow and that line itself will be our HGL. We will be having two lines to represent the flow, that is the one is the TEL and the second one is the HGL. Okay, means what? Look at here, we have a Bernoulli's equation, that is total energy is equal to P by rho g plus V square by 2g plus Z. In this one we are going to say that here P by rho g won't be there because this is the gravitational force. flow and there is no pressure, therefore in this Bernoulli's equation I can say P by rho g will not be there. Then what is left? That is your energy is equal to V square by 2g plus Z. Kinetic energy and potential energy both will be present here. Pressure energy will not be there. Therefore, your HGL and the surface line both are same here. Now we will discuss about the difference between pipe flow and open channel flow. Just remember, pipe flow is already thoroughly studied in the previous semester. Thinking that I am going to teach you the difference between the pipe flow and open channel flow. See, in pipe flow, total energy means what? In pipe flow, total energy is P by rho g plus V square by 2g plus Z, means pressure energy, kinetic energy, potential energy. All three energies if you add, then you will get the total energy in pipe flow. When you come to open channel flow, pressure energy is not there, only V square by 2g and Z, means kinetic energy and potential energy. Only these two are there. When you come to the representation of flow, that is your TEL and HGL. In pipe flow, TEL and HGL, of course, they are parallel to each other, but that HGL is not coinciding with the surface of the water. But when you come to open channel flow, the surface itself acts as a HGL. Then the direction of the flow. In pipe flow, the pressure can be positive pressure, negative pressure. Therefore, the flow may be upward direction or it might be downward direction. Both can happen in a pipe flow. But when you come to open channel flow, here the flow is always downward because it is a gravitational flow. Then, if you come across the cross-sectional areas, if you know, then what about the cross-section? Before that one, you should know the meaning of prismatic and non-prismatic. Prismatic means if any channel has a cross-sectional area constant throughout the length, then that is called as a prismatic channel. If the cross-sectional area is not constant throughout the length, then that is non-prismatic channel. Okay. Prismatic channel best example is your canals, irrigation canals, or otherwise a small gutters. There, the cross-sectional area for the particular length you are going to keep it constant. But non-prismatic, it may be a river flow. When the river is there, then you will not get exact cross-sectional area everywhere in the length. Therefore, that is non-prismatic. Okay. Now here, when I consider the shapes of the channel in pipe flow, always we will prefer a circular diameter. That is, a pipe is always circular diameter pipe we will consider. There are many reasons for that. That is the only one shape we are going to consider in pipe flow. But when you come to the open channel flow, here we will be having many shapes. The basic one is a rectangular shape, or trapezoidal shape, or circular shape, or semicircular shape, or a triangular shape. Okay, or sometimes you can derive your own shapes like a egg shape or rectangle and semicircle shape. Like that you can invent your own. But in this third chapter we will be discussing four sections: a rectangular, trapezoidal, triangular, and circular. Surface roughness variation. When you are dealing with the pipe flow, the pipes are manufactured. Pipes are manufactured means that roughness of the pipe inside, that is under your control. If you want a smooth, then you will order the brass pipes or steel pipes. Like that you can order your preferences in pipe flow. But when you come to the open channel flow, here there are large variations. For example, in the labs, if you are studying, then you may make a channels with the glasses. Therefore, there will be a smooth surface. When you come to the field, the canals may be made up of concretes. There you will get a rough surface. If you are studying the rivers are completely undulated and rough. Therefore, the variation of roughness in open channel flow is a large, but in pipe flow is a somewhat predictable. Right. Next, dimensional number, you already know that. Pipe flow, we will deal with the Reynolds number. In open channel flow, we will deal with the Froude number. Right? Now coming to the velocity distribution. Velocity distribution in pipe is symmetric about the pipe axis, because at the surface where that water is touching to the surface, there obviously the velocity will be 0. As it goes center, as the depth moves center, then at the center velocity will be maximum. Then again it becomes 0 at the surface. Therefore it is symmetric about a central axis. But when you come to open channel flow, obviously at the bottom velocity is 0, but the velocity is not maximum at the top surface, but it will be maximum nearly 0.05 times a depth from the top, or 0.025 times the depth. There exactly you may get the maximum velocity. The reason behind getting the maximum velocity not at the surface, just below the surface, that I will discuss later. Okay, these are all differences of pipe flow and open channel.